Welcome to Global Information Security Society for Professionals of Pakistan.
Okay, challenge. So yes, assalamu alaikum everyone. So today we're gonna be talking about domain 4, which is cloud application security. So up till now, up till domain 3, what we have talked about is general cloud security architecture, and we also talked about data security in the cloud. So when we talk about cloud, we look at two major things when it comes to security. Number one is data, and number second is application. The applications that we are either developing in cloud or hosting in cloud. So today's topic will be application security in the cloud, and how it is similar or different from development of an application on an on-premise data center, on-premise, in an organization. So there are a lot of similarities. There are differences, and we'll see those things. Again, there will be concepts that we have talked about before. There will be some repeating information, and that information will basically is there to reinforce the concepts, the ideas that we have studied or we have talked about in our previous presentations and discussions. So with that, there will be less of data. This domain will be less focused on data security in the cloud, but it will be more focused on application security in the cloud and what are the best practices around application security and what actually application is when it comes to cloud implementation. So that's in a nutshell what this domain will cover today. Okay. All right. So if you all remember from the previous discussion, we talked about cloud as an abstraction of physical layer. And by abstraction means is that this is a layer that is on top of the physical hardware, whether it be servers, storage, processing, and then all that abstraction that is available through a user via web interface. So if an administrator wants to log into the cloud, he wants to do some configurations, then he has to log into the management plane and he, configure, spin up machines, add new storage, add new processing, add new other areas. So all that is done via web plane, and that web plane or management plane communicates with the underlying infrastructure via APIs. So the language or the thread, or I would say the dots that connect cloud together is the API. So API is the key part of cloud mechanisms, working mechanisms, whether it be functional mechanisms or non-functional mechanisms. So non-functional mechanisms are usually security mechanisms, right? So, so the cloud development in the cloud is also heavily rely on the usage of APIs because of abstraction. So application programming interface, the definition is a software to software communication link that allows two applications like a client and a server to interact with one another over the internet. So API is, again, as I said, think of API as roads that allows traffic to flow between a server and a client. And you do not need to access the application in full form. You can just communicate with applications via APIs. And there are several types of API formats that cloud is using. One is SOAP, and which is also called Simple Object Access Protocol, and REST, which is Representational State Transfer API. So SOAP, one thing you need to keep in mind from the examination point of view is that SOAP is an older protocol, API protocol that was used in the past. The SOAP has limitations, and we will talk about those limitations as in the later slides. So SOAP has limitations, but REST API, which is kind of superseding SOAP now, has more flexibility, it has better security, and it provides more capacity to transfer data in various formats. So this is the major difference between SOAP and REST. So from the examination point of view, you need to understand what is the difference between SOAP and REST and which one is better. And the better API these days is REST API. So just keep that in mind. So SOAP, so what are the similarities between these two APIs, first of all? So SOAP and REST both work across HTTP. We all know the protocol of web is HTTP, Hypertext Transfer Protocol, and they both rely on established rules that their users have agreed to follow. So whenever a client and server agree to communicate with each other, there are some rules that get established. And once those rules are established between client and server, communication happens. But that's just about where the similarity ends. So they are quite different in approaches and implementation. As I mentioned previously, that they both use HTTP protocol to communicate, but that is the only similarity that these two types of API have. And what are the differences? So SOAP is a protocol. So remember one thing, SOAP is a protocol. So that was designed to ensure that programs built in different languages or platforms could communicate with each other in a structured manner, right? So maybe application is developed, server side is developed in one language, while client side is developed in a different language, but they need to communicate with each other. So SOAP framework or protocol provides that translation that two different types of languages or platforms can communicate with each other without any issue. So SOAP, what it does is it encapsulates the data in envelope and then use HTTP or other protocols to transmit the encapsulated data. So SOAP is like a mailman, right? For lack of better word. So you go to post office, mail come to post office delivers the mail, postman takes the mail, put it in the bag and delivers it to you. So you never know where it is coming from, right? It might be coming from an organization, from an individual, but it's coming to you. And the role of SOAP is what mailman does. It delivers that data, it delivers that package to you. So what is the limitation? So the limitation of SOAP is that it only allows usage of XML formatted data. So now on the web, there are multiple ways data is shared across different types of formats, across different type of databases. And one of the very standard way of sharing data, or sharing information is XML, right? So SOAP, the limitation of SOAP is that it only allows XML data to be transferred between two endpoints. We have other data formats like JSON, J-A-S-O-N. So JSON. So JSON is another type of data that basically is now heavily used other than XML. And SOAP just cannot work with that type of data format. So that's the limitation of SOAP. And from examination point of view, it is an important point to remember that REST APIs are better APIs than SOAP. So now, as we talked about, SOAP was a protocol, right? REST API is a standard which is developed to address SOAP limitations or shortcomings, as SOAP was a complicated, slow, and rigid protocol. So REST is not a protocol like SOAP, but rather a software architecture style applied to web applications. So while SOAP is very rigid, REST is a flexible architecture scheme that can use SOAP as an underlying protocol if desired and support data formats such as JSON, XML, or YAML. So SOAP was only supporting XML, but now if you can see, the REST architecture is more flexible. It can use SOAP, but it also supports additional data formats, which JSON, XML, and YAML. So the convenience behind REST is that RESTful services use standard URLs and HTTP methods like get, post, and delete to manage resources. I mean, developers or web developers, they're very familiar with HTTP methods. So REST basically use the same method. So you do not need to learn anything additional to implement REST. If you know how web communication works, web programming works, you can easily work with REST APIs. And one thing is that the penetration testing or vulnerability assessment of REST APIs is very similar if you are testing a web application, because you can use same tools, same methodology to test API security as you are testing a web application security. For example, you can use Burp, you can use NetSparker. These are the tools, Zap Proxy. These are the tools that are available. These are very standard tools that are used in the industry right now to perform these security vulnerability assessment of web applications. Same tools can be used to test REST APIs because they're using HTTP methods. Any questions on APIs? Okay. So the next one is going to talk about most common issues in cloud for applications. Now, as before cloud, we are all familiar with how applications are developed on site, right? You have developers, they have access to a development environment, testing environment, production environment. All of those environments are on-prem. Nothing is in the cloud. So if a developer needs something, developer reach out to the production or architecture team or network team or infrastructure team and ask them to spin up a server for them, set up environment for them so that they can do development, maybe install tools for development like IDEs or compilers and whatnot. And in addition to that, developers also reach out to infrastructure team, to set up a development and testing environment where developers actually can test their code, run the application, make sure everything is working. And then from there, they can push that code out into the production environment. And also the production environment is also on-prem. And again, the same infrastructure team gets engaged with developer to push the code out into the production environment and all that. But now things are different, right? We do not have on-prem servers. We do not have on-prem development environment. Everything is happening in the cloud. So what changes over here, right? So we talked about previously that there are issues with the cloud, which are migration and portability issues. So traditional on-prem systems and applications are designed, implemented, and optimized to run in a traditional data center. So when migration to the cloud, application functionality and security may not exactly the same as what you are used to in on-prem environment, right? You might have your own firewall, you might have your own physical security controls in the data center. You might have your own antivirus systems running on those servers and other security controls, which you have full control of, from physical controls to logical controls. But now when you're moving to the cloud, the first thing that is going away is you are losing physical access or physical control of the server, because now you are hosting your application in somebody else's physical environment, right? Which is the cloud environment. So, there are issues that you need to address over there. Then you have integration issues. So when moving to cloud environment, your developers and administrators no longer have the level of control as they have in local implementation. So as I was explaining before, that developers basically can directly talk to infrastructure administrators and ask what they need for their application development, but that's not the case anymore, right? Now there are no infrastructure people, because everything is happening in the cloud. So what happens? What will happen in that case? What will developers do? So that's where, if you remember, we talked about different types of cloud services, which are infrastructure as a service, platform as a service, software as a service. So in development environment, what happens is that infrastructure team usually does not have much role to play now. I mean, they still do, but developers now have more control, because what they can do, they can spin up an environment by themselves. We are looking at infrastructure as code now. Now, previously, developers have to go to infrastructure team to ask them to set up the environment. Now, what they can do, if they're hosting their applications in AWS, they can just use a language called Terraform. And what Terraform does is developers can write the parameters that I need a Windows machine, I need this level of patching on that, I need this software on it, and I need these access controls. And all of that can be programmed as part of the development process. And when developer push the code out, what it does is, in the cloud, what it does is that Terraform codes run in the background, and it automatically spins up infrastructure for developers to work on. And now developers do not need their administrators, they do not need their infrastructure team, because they can do it by themselves. But there are issues with that, right? What are the issues? Issues is that when developers who are not security savvy, they do not know how security works. All they care about is that they need their code to work, their application to work functionally. They don't care about security. They just push the code out into the cloud, and that, and usually developers use a service called PaaS, platform as a service. So they don't have to worry about infrastructure. So developers, PaaS environment is very, very popular with development organizations and developers. So they know they have the platform. All they just need to do is write the parameters in Terraform, push it out, and their environment is up and running. But now the problem is nobody's monitoring that environment. Developers are pushing out code which is which is not secure. It has holes in it, is not properly written. And that basically causes a big security gap in the cloud security of an organization. So these are the considerations as a cloud architecture, as a cloud professional, that you need to understand how development is happening in the cloud. And that is the main core of this chapter. So performing system and application integration without full access to supporting system and services can be very complicated. So APIs provided by CSP help to alleviate some of these issues to integration. So again, as I mentioned, API is the thread. API is the key for everything that is happening in the cloud. So what are various cloud environment challenges, right? I think I've already talked about it, but we're going to talk about it again. So the deployment model are public, private, and community or hybrid, right? Can be leveraged to determine the level of multi-tenancy and may impact application development consideration related to privacy. The service model that we talked about, IaaS, PaaS, or SaaS, being leveraged is most often PaaS for pure application development projects. As I mentioned, that PaaS is the service model that is very, very, very common when you are doing cloud development, because that is, you already have a platform. All the developers need to do is push out this, code and make it work. So the service model determines how much access to the systems, laws, information your development team has. So you need to make sure that your development environment matches the production environment that you intended to use. So for example, whenever you write a code, whenever developer writes a code, before they push into production environment, they have to test that code. And usually that environment is called UAT environment, or user access testing environment. Or in short, it is also called testing environment, right? So most of that time, that testing environment resides in PaaS service model, right? Now, what happens is that if pass does not match in terms of security requirements with the production environment, it may be configured in an insecure way as compared to production environment, then you do not have a true test of how application will work in production environment where all the security controls are implemented, whether it be logging, whether it be encryption, whether it be WAF. So we need to make sure as a cloud architecture, as a cloud professional, to make sure that there is no difference between development environment versus production environment. So we need to work with developers to make sure. And in real world, this is the actual war that has happened between developers and security teams, because security teams are always pushing back, hey, your code is not secure. This thing is not properly set up. You need to make sure. That, but the developer, they don't care about security. They don't care about non-functional requirements. All they care about is function. So they just want things to work. And that's the real fight that you will see in large organizations that is happening. All right, insufficient documentation. So these are the issue in development, and these are very relevant issues. I have seen this in many organizations, that documentation is not there. We will talk about various SDLC methodologies as we move along in this session today. So mature organizations maintain well-documented policies and procedures that guide their development teams through SDLC. So following their policies and procedures help develop efficiency, create applications while minimizing security risks. So I'm sure all of you must have heard about waterfall methodology. These days we talked about agile development methodologies. So these are both development methodologies that are two different methods of a software development or system development life cycle. So with agile, it is very fast. Development happens very fast. It is efficient. It moves things in parallel. But the problem with agile is that there is no document, because nobody has time to write documentation. An exam question, you need to write it down. You will get question about what is the difference between, software, a waterfall methodology versus agile, and what is the shortcoming of agile methodology. And the shortcoming of agile methodology is that there is less documentation, and that is the problem that we are facing. All right, so now we're going to talk about common cloud vulnerabilities. We did talk about it previously, as I mentioned, that we're going to be repeating some of the information that we have looked into previously in other domains from 1 to 3, but we'll just quickly go over them so that it's kind of a serve as a refresher for everybody as to what we talked about. No, there is no standard blueprint or documentation for different methodologies. That was the question that was being asked. There is a Agile consortium, I think. They have a website. You can go there and they actually tell you how Agile actually works. So you can look into that. But as far as documentation, there is none. All right. So there are different, common cloud vulnerabilities. We did talk about access control vulnerabilities, how the access is set up. We need to make sure, principle of least privileges is used, how internet-related vulnerabilities impact cloud, what are data storage vulnerabilities, and what are usage vulnerabilities. So these are main 4 categories of most common cloud issues that we see. Let's go through them really quickly. So access control vulnerabilities, as we know, and I talked about it initially, that cloud characteristics on-demand self-serve means that cloud user can access cloud service whenever they need them. And that is also true for the developers, right? If they have PaaS environment offered to them, they are a cloud user and they can spin up an environment for testing their code. And if they are not properly, their access is not properly monitored, they might have, privileged access into that environment. And that may cause an issue because developers should not have privileged access into cloud environment. And why that is the case? Because it's on demand. They are not going to an administrator and asking them to set up the environment. They're autonomous. They can do it by themselves, right? So it is essential that applications are developed and implemented with the principle of least privilege in mind, right? Providing each user access to only the resources that he or she required to do their job. So in addition to managing users, role and access within applications, developers should be mindful of weak authentication and authorization methods that allow users to bypass built-in security measures such as least privileges. So we are looking at two levels of access control over here. The first level is the cloud level, which is obviously they should not have admin privileges to the management plane or other areas. And the second is that when you are developing the application also have built-in access control mechanisms, right? It could be username and password. It could be two-factor authentication where, you have a soft token or a hard token to log into the application. You have your encryption that should be there. Authorization should be properly set up in applications that are hosted in the cloud. There should be no user escape that they can actually go into admin console and do whatever they need, need to do. So those vulnerabilities needs to be addressed. Then internet-related vulnerabilities. We all know cloud is accessed only over the internet. This is a very basic characteristic of cloud, which is broad network access. And that's why we use cloud, because you can access it from anywhere in the world. And we are accessed, via standard communication protocols, which are TCP and IP and so on. So in most cases, the network being used is the internet we talked about, so which must always be considered as untrusted network, right? So internet is an untrusted network. So this is another basic difference between on-prem data center versus cloud data center. Now, in on-prem setup, developers are basically accessing their servers over a LAN, not over the internet, over the LAN, which is a controlled network, which is isolated from the internet. And that traffic can be monitored. That traffic can be segregated. With the VLANs can be implemented and all that. So you have a lot of control over traffic when communication is local inside your LAN. But now, since internet is, you cannot have same level of control over the internet. So internet is an untrusted network versus LAN, which can be considered as a trusted network. So as such, common internet related activity vulnerabilities like DOS and MITM are major consideration in cloud computing. Then we have data storage vulnerabilities. So the cloud characteristics, resource pooling, and related term multi-tenancy means the data of one cloud customer is likely to share resources with another unrelated cloud customer. We talked about multi-tenancy. I gave an example of an apartment building, right? And tenants living in that environment, and they are sharing the same infrastructure. So there is a chance that, if one tenant in that apartment has his or her door open, other tenant can basically enter into that tenant's apartment and just breach the privacy of that person, right? So doors needs to be properly controlled. Same in the cloud, security controls needs to be implemented properly so the tenants cannot interfere, or tenants cannot go from one computer to another computer of multiple tenants there. Misuse vulnerabilities. So the cloud characteristics measured services means that you pay for what you use, right? It's just like you use water in your house, right? You turn your water, you turn your electricity, and the amount that you use is being measured in your meter, right? Your electricity meter or your water meter, they measure how much of water or electricity you are using. The cloud is the same thing. Whatever the cloud you're using, that could be measured in storage, that could be measured in the amount of bandwidth that you're using when you're communicating with the cloud service provider. So if it is not properly used, then somebody maybe misuse your cloud, and you may get the bill of the usage that you have not even done. So you need to make sure that security controls are in place to avoid misuse. So where this approach can go wrong is when system and application vulnerabilities allow unauthorized parties to misuse cloud resources and run up the bill. So we all know Pakistan mein bijli chori hoti hai, right? So what happens? Aapki line ja rahi hai and somebody ne kanti dali line ke andar, and they just start using electricity. So that's basically cryptojacking. It's a jacking, right? You are stealing electricity or whatever the utility, and same can be happen in cloud, right? An example is cryptojacking, which is a form of malware that steals computing resources and uses them to mine for Bitcoin and other cryptocurrencies. And it happens in your systems, you are paying for cloud service for your user, but one of your system got hacked due to cryptojacking, and now your computer is being used, the processing power is being used to mine cryptocurrencies. So these things happen in that cloud, and hence security needs to be implemented. Any questions? Okay. Now we are going to talk specifically about application security, right? So any system that we develop, it has to go through a cycle. And that cycle, whether it be application development or other types of system development, that cycle is called software development life cycle. So, or in short, SDLC. Now, if you put another S in front of SDLC, it becomes SSDLC. And SSDLC means Secure Software Development Lifecycle. So before we go into Secure Software Development Lifecycle, let's just talk about what is a software development lifecycle. Sometimes it is also referred to as system development lifecycle. But since we are talking about application development, we will call it software development lifecycle. So remember, system and software are interchangeable words. So you can use either of them. There's no hard and fast rule to use one or the other. So now, SDLC, as you can see, has 6 phases. And these phases are planning, which is where you actually start talking about, hey, I need a system, I need an application, and what will that application do? And how will that work? So that's where planning phase comes in. After planning is done, next one is defining actually what that system will do. What is the purpose of that system? And then once you define that, then you have design. And design phase, and each phase has its own activities, and we'll see those activities in later slides. So in designing, you basically come up, you sit together, you do brainstorming, and you select how you're going to design that application. What language are you going to use? What is the purpose of the application? What security you're going to be implemented? What are other features that will be part of that application? So all of these activities will be part of the designing phase. Once that is understood, once that is agreed upon, then we move into development phase or developing. And that's where the actual meet, where programmers get involved, where they take the requirements that are established in designing phase, and they're actually now starting to write the code based on the planning, defining, and design phase, right? So at this point, developers are writing code, they are testing code, multiple people are working together, infrastructure people are setting up the environment, or cloud environment is provided. And once after development is done, then you go into testing phase. In testing phase, you basically test, okay, whatever we talked about, whatever we agreed upon in defining and designing and development, it is working as intended. There are no issues. So in testing phase, there are two major forms of testing that is performed. One is functional testing, and the second one is non-functional testing. Functional testing is when you actually look at, okay, if I click this button, this should happen. When a username type in his username and password and he click login, the user should log in. Once after login, if he needs to log out, he needs to click log out. And once he log out, he should log out. There are no active sessions. So these are the type of functional testing that needs to perform. Non-functional testings are generally called security testing. And that's where you as a cloud security professional or application security professional comes in and do those type of testing. And that will include maybe SAST, DAST, penetration testing, software composition analysis, all of those security testing, fuzz testing, everything that is part of this. These activities are part of security testing. And from testing, application goes into the deployment and maintenance phase, where basically users are actually using the application. There's maintenance that is happening, new patch is being released, new feature is being released. So all of those, servers are being updated, code is being updated. So those are all the activities that happens in deployment and maintenance phase. Any questions in SDLC? Okay, let's move on. So we'll just go through them. I know we just talked about briefly, but I would like to go over this slide as well. So planning phases is the most fundamental stage in SDLC, and is sometimes called a requirement gathering phase. So requirement gathering phase and planning phase is one and the same thing. So during this initial phase, the project scope is established. A high-level requirements are gathered to support remaining lifecycle phases. And the planning phase is where risk should be initially identified. And this is a very crucial sentence of this planning phase. What happens is that security is, generally speaking, even today, is an afterthought. That application has been planned, defined, designed, and deployed, and nobody thought about security. So that's where, being a security professional, you need to be considerate and working with your development teams, that security is part right from the get-go, right from the beginning, right at the planning phase. You are talking to developers, you are looking at how you're telling them what the security requirement is, and you need to make sure that your security requirements are considered right from the planning phase, right? So that's why this line, the planning phase where risk should initially be identified, is very, very, very important. So your project team should consider what may go wrong and how you can mitigate or lower the impact of those risks. Then the next phase is defining. So you may also see this phase referred to as requirement analysis phase. So during the defining phase, you use all business requirements, feasibility studies, and stakeholders input from planning phase to document clearly defined product requirements. So it is pretty straightforward. Then designing phase is where you take your product requirements and software specifications and turn them into actual design plan, often called design specification document. And we talked about documentation, and this is the documentation that is very important that all mature organizations should have. So that if your people leave, your programmers leave, new people come in, your architect leaves, new architects comes in. So they have to have those documentation. Security needs to have that documentation on how an application is designed. And if there's no documentation, it takes long time to understand somebody else's code, what they have written. I'm sure if some of you have developer background over here, they can verify, they can vouch that how difficult it is if a code is badly written, if the function are improperly defined, if in the application the commenting is not properly done, it's a pain to deal with that code if somebody else has to read that code. So that is where documentation is very important, right? So the fifth stage is developing, and that's where, during this phase of SDLC, your development breaks up the Word document in previous steps into pieces or modules that are coded individually. So database developers create the required storage architecture, front-end developers create the interface that users will interact with, and back-end developers code all the behind the scenes and inner working of applications. So generally speaking, in MVC infrastructure, you have a front end, you have a middleware, you have backend, and you have databases. All of these are different components of an modern application. So somebody is a UI developer, which is user interface developer. So he's, looking at how the website will look like for the user, or how the software will look like to a user. And then there are people who are developing the middleware, the logic, the business logic, and translate that into code and make it work. And then there are people who are writing the backend code. There are people who are managing the database and creating the database. So all of these activities from front end to back end happen in development phase of SDLC process. And then we have testing. So once the code is fully developed, the application enters the testing phase. So during this phase, application tester seeks to verify whether the application functions as desired and according to the documented requirements, if there's documentation. The ultimate goal here is to uncover all flaws within the application and report those flaws to the developers for patches. So, and that's where, patch testing, we talked about it, so I don't think I need to repeat that, but it's pretty clear that what happens in testing phase. And the last one is deployment and maintenance phase. Once the application has passed testing phase, it is ready to deploy for customer use. There are often multiple stages of deployment. Alpha, beta, and general availability are common ones. There's also, I'm not sure if you have heard about red or green deployments. Those are basically two deployment environments, and they work simultaneously. I'm sure if you have watched Netflix or Prime, sometimes it so happens, or Facebook even, Twitter. So what they do is they call it blue-green deployment. So they deploy a new feature, which is only available to certain users around the world, right? And then that feature may not be available to the rest of the world. So what's happening over there is that they only push that feature out in a blue deployment and direct traffic of certain area to the blue deployment. And that's where only that users in that geographical area can see those features. While users who traffic is coming into green deployment, because the feature is not available, they are not able to see that feature. So that's what we call a blue-green deployment. So now, if the blue deployment is working properly, then what happens is the same feature then gets pushed into green deployment, and that is made available to the rest of the population. And that's how they are testing and deploying at the same time. So it's called blue-green deployment. So these are different methods that you can use. So during the maintenance phase, the production software undergoes an ongoing cycle of SDLC processes where security patches and other updates go through same planning, designing, development, training phase, and discussed in the preceding section. Any questions on SDLC? All right, let's move forward. Methodology. So we talked briefly about methodologies. So there are two main SDLC methodologies or development methodologies. So these are generally called SDLC methodologies, but people just refer to them as development methodologies or methodologies. Waterfall, which is the oldest one, in waterfall, it is very slow. It takes a long time to develop an application under this methodology because you have to first have a design, then you have to have documentation. Once the design is complete, only then you go to, next stage of SDLC. Once that is complete, only then you go to the subsequent. So I mean, look at how the waterfall works, right? If you go out in nature and see a waterfall, from top to down, water first flows from the top, then to the second level, the third level, and the fourth level until it reaches at the bottom. So that's how waterfall works. And that's the same concept over here. And waterfall is a very slow development methodology. And that's where Agile comes in, right? So Agile is more of a new kid on the block type of methodology. It was introduced in 1990s. So in this method, instead of proceeding in a linear and sequential fashion as was in waterfall method, development and testing activities occur simultaneously and cyclically. So I've talked about blue-green deployment. That is one of the outcome of agile development methodology, because both of the environments, blue deployment environment and green deployment environment, are in production. The users are actively using, but you can test at the same time you are testing. You do not need to have a separate testing environment. You can use development environment as a testing environment. And that's one of the key features of Agile. It is fast, it is quick. So application development is separated into sprints that produces a succession of release that each improve upon previous release. So with Agile model, the goal is to move quickly and to fail fast, create your first release, test it, fix it, and create your next release fast. So what does it mean? So in waterfall methodology, you have to do first thing, you develop something, you test something, only then if it is working, only then you go to the next stage. In Agile, you don't have to do that way. You are releasing fast, and if there's any issue, you're fixing the issues right there and then release a new version right there and then. So production and testing is happening, and fixing, everything is happening in parallel. No stage is waiting for the previous stage to finish to do the next one. So it is quite fast. And what is the downside of Agile? The downside is no documentation or less documentation. And that is the downfall. No, so waterfall was pretty old. I think since maybe in 80s or early 70s, I do not know exactly. Waterfall is similar to PMP. No, PMP is project management idea, and waterfall is part of PMP. As I said, one of the methodology that PMP people study, project management people study, and how to manage projects that are done using waterfall methodology. Agile or DevOps is the same thing. They are not the same thing. Agile is again a methodology. DevOps is an idea, right? So there is a difference. So Agile is a methodology, as we talked about. DevOps is an idea where two things, dev, which is development, ops, which is operations, they work in tandem to make sure that application development process works in much cohesive way. So that's what DevOps is. And then if you add security to DevOps, it becomes DevSecOps. So DevOps or DevSecOps is more of a culture in an organization than a methodology. Agile is a methodology. Does it make sense? Yeah, people usually confuse DevOps and Agile, but again, DevOps is a culture, Agile is a methodology. Okay, applying the SDLC process. So now we have an understanding what SDLC is, how development lifecycle works. We haven't talked about security as part of SDLC. So what makes SDLC and SSDLC? There is another concept in SDLC, which is very tactical concept, and that is part of DevOps and DevSecOps culture. What we call is a CI/CD pipeline, right? CI means continuous integration, CD means continuous deployment, right? So Agile, DevSecOps, CI/CD, all of these things work together when it comes to development, right, of an application or a project. So in software terminology, CI/CD, think of it as a production line. You know, if you go to a factory, any factory, manufacturing factory, we talked about, you know, a line, right? A line is where factory workers stand and they do different things. So for example, if somebody is making a toy, right? So in a line, somebody has to put plastic bits in where, you know, the plastic is melt down and, you know, add colors to it. And then from there, the plastic goes into a mold where the toys take the mold in that line, and somebody is there doing that work. And from there, that mold goes into the next phase in the line where somebody is inserting a battery or some other mechanism in that toy. And from there, somebody's doing that. Again, on the same line, that toy goes to the next person in the line, and that person's job is to, you know, fine tune, make sure everything is working, do some quality test on that toy, make sure it is working as intended, right? So that person might be the QA person in that line. And from there, it is going into packaging, and where, you know, final packaging is done. And from there, that toy goes into shipping, right? So same concept applies into software development process, and we call that process CI/CD pipeline. And pipeline is the same, you know, idea of toy development that I just gave you. Is basically the first person is writing the code, and that would be on his workstation. And that's basically, and this all is happening in the SDLC where the development is happening. This is not happening in design phase or requirement phase. This is happening in development phase, right? Every phase has different activities, and what we are talking about is all in development phase, right? So CI/CD pipeline happens, somebody writes that code, codes get into the build process. After build process, it goes into the next phase, which is maybe a testing phase, and from testing phase, it goes into production and gets integrated. And also, there are a lot of things happening. Now, in that process, you need to implement security. Either you just develop and don't test anything and push the code into production with all the vulnerabilities. What happens? Hacker's gonna hack that application. But once you apply security as part of the SDLC process and the development phase, you improve the quality, you improve the security of your code that is going into production, whether in cloud or wherever the case may be. So the most common vulnerabilities during development phase in SDLC format is collected by OWASP, which is Open Web Application Security Project. It's a very good project. Everybody should go to owasp.org and explore their website. You will find a lot of information about software development and issues and various projects over there. You know, OWASP Top 10 was last updated in 2017. And based on what the data that they have gathered from all over the world, what they have seen is that up till 2017, these are the 10 most common vulnerabilities that applications have. that they have found in the world. And those are injection, broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfiguration, XSS, insecure decellularization using components with known vulnerabilities, and insufficient logging and monitoring. So these are the top 10 issues that we have seen, or they have collected over time, that are observed in a lot of applications. I think they did have now a newer version of top 10 that just recently came out. But for the purpose of this test, certification, they are focused on 2017.